Hi, Subramanian. Can you confirm if I'm audible?
Yes.
Hello, everyone. Welcome to today's webinar. I'm Abhay Naik. I'm associated with Desapex as Digital Design Manager. We here at Desapex have come up with this series of webinar to help our clients and people in this AEC community to better understand the technologies available in our industry and how it can be used to address different challenges we all face in our day-to-day projects. So today I will be talking about reality capture for renovation projects and how reality capture is helping the architects and engineers to design and renovate the project faster and accurately. Our today's co-speaker, Ekta Chopra, who is principal architect at Eka Studio, is a little unwell and would not be attending the webinar. So I would be taking you through till the end of the webinar. Before starting our webinar, I'm going to brief you about the agenda of today's webinar. So first, we will discuss the challenges faced during renovation project. Then I would give you all a brief introduction to Desapex. We will later discuss how reality capture technologies can support renovation projects. We will also understand laser scanning or LiDAR survey and reality capture, discuss the digital framework for implementation of laser scanning in your project. I'll talk about few of the case studies of the projects what we have delivered, and then at the end we'll talk about the advantages and key highlights of the in which we have implemented laser scanning. And at the last, we will have a question and answer session. So the first part, coming to the major challenges faced during renovation project. So the building owners does not have any drawings related to the building. This makes the renovation process very challenging to the architects and designers, and the renovation can only be started once the as-built conditions are captured. Another scenario is when the building owner has the drawing related to the building, but it is not matching, as they are either old or their substantial changes might have happened after substantial changes might have happened, like a small project or a minor renovation after the drawing was created. So using such data will only mislead the project team and will impact the cost and time planned for the renovation project. Capturing the data using conventional method is relatively slower, and there are high chances of missing data. So what happens is, when we do manual survey or measurements, usually it covers only the major dimensions, but important piece of information, it might be like the connections, transitions, etc., are missed in the drawing. Manually measured as-built drawings are prone to errors because human efficiency tends to reduce as the day passes due to fatigue and might wrongly read or record data captured at site. This leads to major issues while renovation and impacts increase in cost and time of the project. Capturing with manual methods, it is hard to measure information of confined spaces and hard to reach areas. Even working at height to get measurements is high risk method. So it also requires a plan to arrange ladders, scaffoldings, scissor lifts, which requires a lot of effort and time. So the amount of manpower and the time spent on capturing the information is not actually justified. Then we have this high side infrastructure. So majority of the time, what happens is the high side infrastructure remains the same in the renovation project, and capturing it accurately is important, as the renovation design or the fit out design is worked in line to it. So with conventional methods, we cannot achieve higher accuracy of data capturing, which leads to rework at site, and it reduces the system efficiency on a longer run. For few renovation projects, capturing the structural detail plays a vital role. So it might be to plan a room which requires higher structural loading capacity. So it might be a battery room or any other room which needs a higher loading capacity. So the new layout depends on the core structure design and helps architects and engineers to identify the strengthened area so that it can be rightly positioned in the as per the design requirements. So rework due to inaccurate data. So rework is a major aspect which offsets the project cost and timeline. The majority of the rework are due to inaccurate data of the existing conditions which are considered while starting of any renovation project. So the summary is, renovation is another phase of construction where either the building is very old and the documents are either in the dilapidated situation or they are not preserved, or minor modifications made over the years were not updated into the drawings. So using laser scanning technology, we can create a digital twin of the facility, and the model can be used to estimate, plan, generate renovation projects. So here I introduce you to our very own digital engineering company, Desapex Engineering Consultants, which provides various digital technology services to address your construction issues. So with a quick introduction about Desapex and the services offered, we will come back to the topic and discuss solutions available. So Desapex is a digital engineering organization working towards digital technology integration in the architecture, engineering, and construction industry to improve the life cycle of your built assets. We provide complete digital solution throughout the life cycle of the building or infrastructure, that is while the design stage of the project, construction stage of the project, operation and maintenance stage of the project, and also the renovation or the demolition stage of the project. We have different services. Desapex aims at creating a sustainable built environment by enabling digital adaptation and integration of technologies for target value design. We are headquartered at Bengaluru, and also we are operating from 3 major cities in India, which are Hubli, Chennai, Hyderabad, and we serve our clients across the globe from these offices. We also have an office in Sweden. Our team from Sweden office are helping our European clients to digitalize their properties. So we have experience working with major customer segments, which are hotels and restaurants, corporate real estate, data centers, logistics and warehouse, retail, and many more. The uniqueness about Desapex is that we have a kite mark certification from BSI for ISO 19650. So this is a global standard certification for BIM information management. We got this certification late back in 2019 from BSI, where our projects were audited and we were certified. So I feel very proud to say that we are the first company in the world and only company in India to have this kite mark from the British Standard Institute for ISO 19650. So we have a young, passionate team, and we have civil engineers, mechanical engineers, architects, BIM engineers who proactively learn the latest technologies to mesmerize our clients with unique solutions. We are always looking for professional certification to upgrade our core technical capabilities. The unique approach of Desapex is that we have people who have knowledge on the tool, processes, and the domain. So this is really a unique approach, as in this industry, we find people who have either knowledge on the tool or on the process, but the domain knowledge along with it is a game changer. Now we will talk about the 3 verticals of Desapex. So we have 3 verticals at Desapex. The first one is the digital design management. Other one is digital project management. And then we have digital asset management. Under digital design management, we provide architecture, structure, MEP, modeling services. Then we provide clash detection and coordination, clash resolution services. And then BIM-based pre-construction services might be to create drawings or simulations. So that is provided under digital design management. So then coming to the digital project management, here we have digital information delivery plan, technical due diligence, and we help our clients to set up their digital labs at the site so that the model can be used by the construction team to visualize and build better. So then we come to digital asset management. So in digital asset management, we have scan to BIM, so where we use the laser scanning to convert the built facilities into BIM model. So then we support our clients for energy and maintenance management and asset management. So under DDM, so what we have is we provide architecture, structure, MEPF modeling, clash detection, coordination, BIM-based pre-construction services. Since the adoption of BIM is increasing among architects and engineers, so there is still a gap. So both in terms of capacity and capability, it must be bridged to create a digital 3D model. So at Desapex, we help our clients to convert the conventional 2D drawings into the 3D BIM models and perform these simulations before even we have to go to the construction site. So under DPM, here we help our owners to create a set of contractual documents stating the BIM information requirement, might be at the capital expenditure capex phase of the project, or might be the opex phase of the project. So this solution not only includes setting up information exchange standards, but also continues managing the project in a digital environment, be it 3D model checking or auditing. So the common data environment setup, BIM execution plan development, lab setup for BIM at site, augmented reality or virtual reality, digital progress monitoring. So these various services are provided using the hardware and software technology like LiDAR scanning, 360 photography that help progress reporting to client virtually. So this creates transparency between all the stakeholders and the client at site. So then coming to digital asset management. So we assist our client to digitalize their project documents in terms of the latest as-built 2D drawings. So we use laser scanners to convert the existing physical assets that are static buildings into a digital twin and connect it into a dynamic data incoming from the BMS, EMS, and other IoT devices at site. So with this, we can do maintenance management, energy management, predictive maintenance, and asset information management. So we are partnered with this Finnish company called Grandland. So we have an integrated tool called Grandland Manager, which can also be used to provide the solutions like BIM for facility management, in which we provide maintenance management, energy management, asset management, and also real estate portfolio management services using BIM models. So digital twin using reality capture. So here we build models using laser scanner technology. That is nothing but we are going to develop BIM model using reality capture, and the model can be further used for as-built verification, documentation, and also for construction progress monitoring. So we are not just into 3D modeling or clash detection. Desapex has expertise into various business requirements. So it might be helping you make your factories industry 4.0 ready, or some geospatial technologies to map your properties. So anything with respect to smart cities. So we have a wide network. So you can always get in touch with Desapex to understand and see how we can address your requirements. So now this is all regarding Desapex introduction. So we'll come back to our today's webinar topic. So here we will talk about the benefits of reality capture for a renovation project. So first thing is regarding the quality of data what we'll be getting for a renovation project when we use reality capture. So laser scanning data is a very efficient, accurate, and detailed data. So the scanner records almost 2 million points per second. So you can, it takes almost 3 to 6 minutes to capture one area, one scan point. So each scan point is having an accuracy of up to like 4 mm accuracy. So hence the model derived from scan to BIM is more reliable and is of assured quality. So with respect to saving of time, so the fewer site visits is required for gathering the building information modeling. So what happens in renovation project is basically we might have missed some information, so we have to revisit. The project might not be in the same city, so we need to fly down to the city and get the data, or send somebody locally and get the information. So it is all we are wasting a lot of money and time to do this. So what happens is once you do the laser scanning, you have the data on your desk. So any area or any point you want to verify, you can do it using this laser scan data. So minimal errors. So yes, as there are fewer errors, the site challenges are very minimal, and this saves a lot of time and money and decision-making time. So whenever you have errors in the input data, even when you do the retrofit design, there are a lot of errors. So a lot of site decisions have to be taken. So using laser scanner, we can avoid this. There are very minimal locations where you need to do the decision making. So that is one of the benefits. So then coming to the sustainability part, so using BIM model at every building process leads to a better sustainability in the project. So this model can be used from the as-built stage, so from when you have captured it till the demolition stage of the project, so which brings sustainability across all the phases of the project. And then we will come to how to save cost. So we all know that site challenges could hold up the entire project and result in financial and schedule losses. So with the help of as-built BIM, we could be able to minimize this site decision right at the planning phase of the fit-out project, since an accurate model of the existing building is used as a benchmark for all renovation works to come. So typically resulting in cost reduction. So now, I guess a few people who have attended this webinar today are new to scanning process. So I'll just touch base on what is scanning and how the process is. So then we will move into the framework, and then we'll talk about some of the case studies and how our clients are benefiting out of it. So coming to laser scanning. So laser scanning is a non-contact, non-destructive technology that digitally captures the shape of the physical object using a line of laser light. So the scanner emits laser beams, so which hits the objects or all the elements which are available within the building. And once it bounces back, it records it as a scan point. So it creates a cloud of points. So when we keep positioning the scanner in different locations, it captures a cloud of points, and it can be used to develop a 3D model. So we provide 3D laser scanning in various formats for scan to BIM 3D modeling service. So after collecting the data, 3D scanning, it is developed into a point cloud. So first what we do is we plan the site. Plan the site is basically to understand the complexity of the site, how big is the site. So once that is done, the scanners are being sent to the site. The scanner scans the building, and then processing of data. Processing is like registration or alignment or stitching the data together, and then publishing the data into a 3D model. So few of the images of our scanner and team scanning in different parts of the world. So here, the first step, what you see is scanning. So what we position the scanner at the site, so wherever we have to capture the facility, and first we capture it. So once the data is captured, the next image what you see is the point cloud data, what we have got from the laser scanning. So once we have the point cloud data stitched together, exported into a format which supports for 3D modeling, so that is sent to a 3D modeling team, who then convert all this point cloud data into different services. So it might be a wall, column, structural elements, MEP services. So all these things are taken from the point cloud data, and they are modeled. So then we can extract drawings from out of it. So all the 2D drawings required might be the floor plan, RCP, sections, elevations, everything can be extracted out from this BIM model. So first is the scanning process. Here we can do above ceiling, below ceiling scanning. We can scan the shaft, trenches, tunnels, and then the registration part. So registration is where multiple scans are stitched together to generate it into a one file. So then the modeling team picks this registered file, and then they use different tools to convert it into a 3D model. And then once it is converted into a 3D model, then we can extract drawings, BOQs, we can comparisons, we can have the renovation design done. So all these things can be done. So this is the framework what is used in any typical scan to BIM project. So scan data, you can see here, this is of the same location. So on the left hand side, what you see is the point cloud data. So this is basically used to convert the site conditions or the scan data into point cloud data into BIM model. So on the right hand side, what you see is a true view data. So true view data we use for training purpose. There might be some new person joined into your team who has to be inducted. So it can be used for induction. And this data also can be used for measurements, to walk through, to visualize any area for meeting, so some breakdown, so you don't need to go to the location and discuss, so you can use this data and discuss how it can be resolved. So different use cases by different clients for all these outputs. So now we will come to the important part, that is case study. So here today we will discuss first about a residential project for which for interior renovation we have used laser scanning. So this is a villa here in Bangalore. So the interior works had to be done, but there were no drawings. A lot of from the initial plan, there were a lot of site changes which were done by the client, which were not drawn back into the drawings. So what we did is we went to this facility. It was approximately 8,000 square feet, including the floors and the outside area. And within 4 days, we with like 1 day we captured the site, and within 3 days we converted everything into a drawings. And by 4 days it was delivered to the client, the as-built drawings. So here you can see all the sites. So you can walk through. You can see what are the available currently available infrastructure, where are the receptacles. So all these things can be visualized. So every time if you want to re-verify anything at site, you can just use this scan data and you can do it. You can also do measurements. So here you just have to select the first point and the second point where you want to take the measurements, and it will show you the dimension. Not just horizontal, we can take even the bottom of slab or bottom of column. So all these dimensions we can take. I'll just show you how to do that. So these are different possibilities. So these are different use cases. So some information you might have missed, whether the skirting is there or not at site, and what is the skirting height. So you don't need to again go back to the site. So it can be all measured from this scan data only, and you can verify it. So this is the beauty of having laser scanning, where the data is so rich that you can use it for multiple use cases. So now we will also see the BIM model after this scan data, how the BIM model looks, and last we will see the drawings that were submitted to the client, which they used it for their renovation project. And not just 3D model can be extracted into different formats. So some formats which support architects like SketchUp and any other tools which they use. So it can be exported into different formats and given to them. So this is the 3D model, what was developed from laser scanning. So this gives you an idea on how the model is and how it has been developed. It looks very realistic and captures all the fine details. Toilets. So all the information is captured. Kitchen. So now we will come to the drawings. So these are the drawings which were extracted. So it captures the site, the tree locations, the services which are there, the floor plan, the ceiling plan, to fan locations, the building elevations. So everything is captured, the terrace plan, the first floor plan, the ceiling plans. So more sections, elevations also were produced. So then coming to the production line renovation for process change. So in this project, the client had a major change of their process to optimize and speed up, and there was a product line which was changing. So here what we did is they wanted the actual condition of the plant, the exact locations of the conveyors, the pneumatic lines which will support different tools in the factories. So all these things were required. So here renovation was of the assembly line of the home appliance, what is being produced in this factory. So what we did, we visited the site and we did the laser scanning of that particular line, and we converted it into a BIM model. So this BIM model captures all the required information what client had told us to put into the model, the pneumatic lines, the conveyors, the pneumatic drivers, the cable trays. So all this information were put into the model. So then this model can also be taken for simulation purpose. So client was using these models for some purpose, so simulation purpose. So for renovation, then we gave them some drawings. So then coming to case study 3. So here, this is one of the factory building. So it had to be retrofit into an event space. So it is a very old building. So there were no drawings available because it was almost closed for more than a decade. So no information relating this building, but it was in a good shape to be renovated and used for some other purpose. And it was in a very prime location. So it was helpful for a client to use it for some other purpose than keeping it empty. So to create drawings in a very short period and converting them into 3D model and then extracting drawings out of it and giving to the client was awarded to us. So what we did from inside and outside, we scanned this entire facility and then using laser scan data, we converted all these structural elements, the door window positions, the levels and everything we converted, and we submitted the 2D drawings and the 3D model to the client. So this was for the renovation project to convert it into a convention hall. So some of the drawings which we extracted and submitted. So sample drawings. Now we'll come to the advantages and key highlights of implemented projects. So when we are using, sorry, so when we are using laser scanning technology, we don't need to always reach the element. So if you have to measure a beam or a column capital or a facade, so you don't need to reach there, which means our dependency on the scaffolding is reduced. Just think the time required to assemble, disassemble the scaffolding or even repositioning a ladder is a saving of both money and time, which means it is the fastest and the safest way to develop the as-built drawings. The data accuracy with laser scanning is high as 5 mm. So which means lesser chances or no surprises when we are planning or constructing. On-time activity of capturing data. So one time compared to the manual survey, here we can have the record of the site condition, which can be used anytime from our desk to re-verify any data. So this is an additional benefit that we don't need to rush to the site for any missing information. So saving the travel time, transportation cost, and a lot more. The same as-built model can be used for design, analysis, and simulation by engineers. So all the stakeholders involved in the project can use this same data for their part of work. Few of our clients have used our service for workplace redesign and optimization of seating capacity. So this helped them to increase the seating capacity while adhering to all the codes and standards. Design option can be worked into the same model in future. So whenever you want to do some localized design update, like for the factory where we were doing renovation or redesign of a particular line, assembly line, so we can only update that line, which makes and the shop drawings can be extracted and submitted to the site. So which makes it really helpful and keeps the site drawings up to date. So we can extract the shop drawings of particular area from the same model. So all these as-built models can be further used for facility management, operation management throughout the asset life cycle. So this is not just for clash detection, coordination, or as-built recording. These models are so capable that you can take it to any CMMS platform, and like we have a Grandland manager, or you can use these platforms, asset management platforms, operation, and you can use for facility management, operation, and maintenance. And then, so scanning can be used for validation of projects at various renovation stage. So before demolition or after demolition. So if the client wants to know the amount of demolition, the site can be scanned twice. That is, one is before the demolition and one is after the demolition. And you can find the exact area where the demolition is done and the quantity. So similar with the renovation works also. So once the demolition is completed and after renovation, if you scan, you can know exactly how much quantity of material has been put into renovation. And this really helps our client for bill approvals and certifications. So these were a few of the important advantages of laser scanning for renovation projects. There are a lot more projects what we have done for our clients for renovation, bringing the as-built conditions into the drawings and models. And we have shown you some samples. Some data cannot be shown here due to NDA and other things. So in future, if you want to know more about what all the different services we have provided, how we bring the data, complexity, so we can please get in touch with us. We can do it. So these were a few of the important advantages of laser scanning for renovation project. So now we would enter into the last part of the webinar, that is the question and answer session. So please drop your questions so that we can answer them. So the first question is, can we capture above ceiling data? Also, can we capture above ceiling data also using laser scanner, and how accurate the data is? So yes, so we can use, see, it also depends on the type of ceiling. Okay, so some areas you have the grid ceiling, somewhere you have gypsum ceiling. So if it is possible to cut the gypsum ceiling, we have to mark particular locations and cut the gypsum ceiling and take our scanners above and scan it. So if it is grid ceiling, it is easy to open the grids and then take the scanner above the ceiling and capture all the above ceiling data. Yes, it will be accurate because we'll be not scanning it from one location. So we'll be taking multiple scans above ceiling. So which data will overlap and stitch together, giving us a clear view of all the infrastructure which are above the ceiling. So one more question is, does the scanning show members only as framing members, or can it show it as a concrete or masonry, etc.? So here, what happens is, this is initially I told this is a non-destructive method. So non-destructive method is, it does not see inside what is there. But for example, if there is a wall and there is a column, so we can identify the difference between the wall and the column, if possible, if it is not flushed together. So it can be differently shown. Or in some cases, what we have done is, in some of our projects, so it might be a column cladding might be there. So column cladding will not give you the exact size of the column. So this column cladding basically stops at the ceiling level. So what we do when we do above ceiling scanning, we can get the exact shape of the column, exact size of the column, and how it is been connecting with the column capital or with the slab. So this is possible. So we can do that. So another question is, what is the accuracy level we can achieve and how long it will take to process the data? So accuracy level, as I said, when we position the scanner at every equal interval, that might be every 6 to 10 meter based on the density of the services, the accuracy is up to 5 to 10 mm. So it is not more than half an inch. So this is because when we position it in different locations and when we scan it, there is a lot of overlapping data which is coming, which verifies itself. So if there is any error when we are doing the stitching or when we are doing the registration, these errors are highlighted. So unless until you align these scan points together, so you cannot take it to the modeling because it will show double data and all those things. So these are very accurate models because it is scanned from multiple locations. So the object is scanned from different directions. So there are a lot of overlapping data and it is accurate up to 5 to 10 mm. There is one more question. Please brief on the cost for scanning. So it actually depends on what you want to model. So some clients, they require only the structural part. So some clients want the structure along with all the MEP into it. So some client also wants the topography. So we also have done projects where before backfilling, the underground utilities have to be scanned so that for a large like manufacturing facility tomorrow for operations, they can use the geo coordinates and they can find the exact location of the pipe or any walls or joints or future provision. So this actually is a very wide subject or question. So you can please contact Desapex, so they will tell you based on your requirement what is the costing for this. So another question is, can multiple scanners be used at a time to speed the scanning process, and can this data be stitched together? So yes. So for example, I'm using 3 scanners. So all these 3 scanners we can scan at the same project and same time, and all this data while registration can be stitched together to make it as a one thing. So it is not necessary that if you have to use only one scanner, you can use multiple scanners and bring all this data together while you are doing the post processing or the stitching of all this data, and you can give it to the modeling team. So one more question is, how scanning is planned for multi-story building having 10 floors? So how scanning is planned for multi-story building having 10 floors? Okay, so what we do is basically there should be overlap between all the floors to know the right levels. So we scan the staircase, which is the common thing for everywhere, and take some overlaps in each floor. And then when we start scanning the floors, so we get the overlapping and we stitch them together, and the modeling is been done. So can you explain how you can know the quantity used in construction? Can you elaborate example? Okay. So quantity, I'll take example of any MEP element. So there are different ways of doing it. So sometimes what happens is client wants to recalculate or do re-verification at site for any ducting part. So using laser scanners, you can exactly take the routing, take the sizes, and take the area. So once you do the 3D modeling, you can directly extract the quantities from the 3D model for any object. So it might be the duct accessories, might be the duct fittings, or the duct flanges, supports. So all these things, once it is put into the model, we can take the quantities out of it. So how do you scan the complete building? It is floor wise. Can you show some videos to understand the process? Okay. So probably not now. I can show any video, but please get in touch with us so that we can give you a complete explanation on different processes and how scanning is done. So it is basically what we do is when a complete building has to be scanned. So we first plan the site, like we go there and see the site, number of floors. So then we start the scanning floor wise. So if there are multiple scanners, so we can start multiple floors, and then we capture the terrace and we capture the exterior of the building by scanning outside. So all this is the process of capturing. So when you capture this, what happens every day when we capture, all this data keeps overlapping on each other, and it stitches when once we stitch it together, it forms into a scanned cloud of point cloud. So this point cloud we will take into the authoring tool and convert it into 3D model. So another question is, does your software differentiate RCC walls and block walls? No. So the software does not differentiate RCC walls and block walls. What we do is this model converting from a point cloud to a 3D model is done by our engineers. So that is what I was saying is our engineers are having the tool knowledge, process knowledge, and the domain knowledge. So these engineers, what they do, they get this scan data, and when they look at it, they can understand what is a column, what is a beam, which are the core walls, which are the what are the block walls. So they differentiate and then they model this. So this is how the differentiation between different elements are done. Is there anything like drone scanning or only tripod scanning? So we have drone and terrestrial both scanning. So it depends on the project size and what is the quality of output required, for what purpose we are scanning. So the floor mounted scanners or the terrestrial scanners what we are using gives us a higher density of point cloud, so it is more accurate. But when you want to model any exterior of the building, might be a facade of a high-rise building, so where manual measurements you might have to do scaffolding, and also that is not required. So here you can use drone scanners. So flying it at different heights and capturing scanners in different angles will give you a lot of overlapping data, which you can bring back and you can do the modeling. So yes, so we can do drone scanning using drone mounted scanners. So I think it was like almost 12 questions, 13 questions what we have answered today. So with this, we would like to end today's webinar. I really thank all the participants for joining today and knowing about how laser scanning can be used for renovation. So I request you all to please get in touch with Desapex if you want to know more about what we do and how we support our clients in their projects. So we'll be really happy to explain you our services and showcase the work what we have done till date for our different customers. So thank you.